So, let's firstly let's review what we talked about in last class. Last class we talked about the factor, right? And how to find a factor. So today, I firstly let me review. Okay, today's lesson is in my book. Today's lesson is 17, and but I rearrange. How to say? But I put them in a different order. Okay, so so in fact, in my book, if you have textbook, today's class is lesson 17, I think. Okay, don't worry. No matter the number of the class. Today we talk about least common multiple and the greatest common factor. Okay, the greatest common factor is the first. This is the common factor, and then this is the greatest common factor. We have three ways to find the greatest common factor. First one is write out all the factors for each number. For example, if I have 12 and 18, I need to find the common factor. How could I do? I just write 12. The factor of 12 is 1, 12, 2, 6, 3, 4.
this woman?
Please. 有问题吗？ Okay. So could I continue? Could I continue? Okay. I just continue, okay? So the factor of 12 is 1, 12, 2, 6, 3, 4. And the factor of 18 is 1, 18, 2, 9, 3, 6, 3, 6. So if I need to find a common factor, you can see the common factor is 1, 2, 3, and 6. So which is the greatest common factor? 6 is the greatest common factor, right? So this is the first method. I just write out all the factors for each number. And the second method is we call this prime factorization. Okay, so for example, 12 and 18. I write 12 equal to what? 12 equal to 2 times 2 times 3. And 18 equal to 2 times 3 times 3. Okay, I just find the common part. The common part is 2 times 3. Okay, so in this way, I know the greatest common factor is 2 times 3 equal to 6. Okay. So firstly, I just introduce these two methods, and then I will talk about this method, or oscillation. This method, because in coding, in coding, we use this method to find the greatest common factor. Okay, so now please try example 1 and send me your answer. Thank you. Thanks for Emily. Emily already get the right answer. So we have, yeah, Siri to give me the right answer. So we have 2 ways. Kevin, give me the right answer. We have 2 ways. Firstly, 45 equal to 3 times 3 times 5. And 36 equal to, according to this question, what we need to do is find the greatest common factor of 45 and 36. So for 36, I have we have 3 times 3 times 2 times 2. Okay, the same part is 3 times 3. Sorry. So this similar so the greatest common factor equal to 9. So this is the reason why I select E. Okay. Of course, we can use the first method. We can write all the factor out and find the answer. Okay. No. Okay. Now we have some basic law about okay, I can't write on it. This one. Close this one. Okay. So if I have 2 numbers, so usually we can use this method to express common factor. If the common factor of A and B, if the greatest common factor of A and B equal to D, and N is a positive integer, so N times A and N times B's common factor, greatest common factor should equal to N and D. For example, if I have 12 and 18, okay, just now I know the greatest common factor of them is 6. Now, I have 36. I have 36 and 54. So the greatest common factor of these 2 numbers should equal to what? Should equal to 6 times 3 equal to 18. Equal to 18. Because this equal to 3 times 12. This equal to 3 times 18. So the greatest common factor of this number is 3 times 6. I write in this way. Okay. Because we can write them in prime factorization method. So the prime factorization of 36 is of 12 is 2 times 2 times 3. And this part is the common part. I just use 3 because 3 is another common part, right? So times together, I get 18. And this is what? Is 2 times 3 times 3, okay? And here, these are other 3. I just time them together, I get 18. So this is the logic why we can use this method. And some other laws, if we need to find 1 and another number, I need to find the common factor. The greatest common factor should be 1. No, because the common factor, because the greatest common factor, always less or equal than both of these two numbers, okay? Than both of two numbers. Should then the greatest, should less than the smaller number, okay? Not all is and. Okay. The minimal number of A and B is always less than the minimal number of A and B. Okay. So A and A, the greatest common factor of A and 0. Usually you can't get this question, but if they ask you the greatest common factor of them is A and is A, because 0 has all because 0 is a special condition. A and B are equal to B and A. You can see this one. A and B equal to B and A minus B. Why? For example, I give you two numbers. It's 12 and 18. Okay. The greatest common factor of them is 6. So when you check about 12 and 18 minus 12, okay, you also get what? You also get this equal to 12 and 6. Of course, this equal to 12. This equal to 6. Okay, and why? What's the logic of this? What is the logic of this? You can see because this can be read as 2 times 2 times 3, and this is 2 times 3 times 3, and this is 2 times 2 times 3. You can see the common part will not change. Right? The common part will not change. This is 3 minus 2 times 2 times 3, right? So the greatest common part will not be changed. Okay. So, try example 2, okay? Okay, so, sorry, I forgot to introduce least common multiple firstly. So least common multiple is firstly is a common multiple, and then is the least common multiple. So for example, I have 12 and 18. The multiple of 12 is 12, 36, 12, 24, 36, and the multiple of them, and 48, and blah, blah, blah. And 18 is 18, 36, 54, blah, blah, blah. So we just find least common multiple is what? Is 36. This is the method 1. And the method 2, I also can use the factorization. The prime factorization is 2 times 2 times 3, and 18 is 2 times 3 times 3. So now we must find a common. So for common, we so in this I have 2, 2, 3. In this I have 2, 3, 3. So for common, I must time. If I need to make them same, so it's something like find a common denominator, right? Find a common denominator. I must times 2 because, sorry, I must times 3 because there are more 3 in this place. Okay, move this to this place, and I times 2 because there are more 2. Because there are more 2 in this place. Okay, so the common multiple is 2 times 2 times 3 times 3 equal to 36. Thanks for Erin. Now these 2 method, and then I will introduce a GCF method. I will introduce this a little later. Okay. So now, yeah, thanks for Aaron and Tony. Both of you already give me the answer for example 2. So how about other students? Kevin also get the right answer. So for Alex, Syria get the right answer. Thank you. So for Alex, this is 6 days off. And for and for Betty, is 4 days off. So step 1, I want to find the common factor of it. The common factor of it. So this is 2 times 3, and this is 2 times 2. So I must times 2 times 3 on both of them, and not on both of 6 times 2 and 4 2 times 3. So in this way, I get what? This equal to 12. This equal to 12, right? And so this is the common factor. So I need to find from Wednesday, 7 days later, this should be Wednesday again, right? 7 days later, this should be Wednesday again. So I must count Thursday, Friday, Sunday, Saturday, Sunday, and Monday. So 1, 2, 3, 4, 5. The 5 is Monday. Or you can write as 7 day, 7, and you can write as 7, 8, 9, 10, 11, and 12. Okay. So 12 is Monday. This is Thursday, Friday, Saturday, and Sunday. Let me check who said something to me. Okay, so what is the GCF method? So let me check about. Okay, so we have a GCF method to calculate this page. I have GCF method, it's special method. I just insert a page. So what's the relationship between GCF, greatest common factor, and LCM? What's the relationship between them? So GCF is easy to find, but LCM is a big number usually. So how to find it? If I have two numbers, these two numbers are big, or it's difficult to find, how could I do? For example, if I have 36 and 48. So the GCF of 36 and 48, just now, I already find it. The GCF, okay, let me, it's 54, I remember. Just now, 36 and 54. Just now give you this example, right? The GCF of them is 18. It's 18. This is an example of just now. But what's the LCM? I can use this method. So LCM equal to number A times number B divided by GCF of A, B. Okay, we can use this. So we can try, does this work? So LCM of them should be equal to 36 times 54 divided by 18. Okay. So this equal to 108. So we just check whether this is the least common multiple. So for the multiple of 36 is 36, 72, and 108. For this guy is 54 and 108. Okay, so we find this is the answer, right? But why? Why this is the answer? We can use this. We can use this graph. So for 36, the prime factor of 36 is what? Is 3 times is 3 times 3 times 2 times 2, right? 36 equal to 3 times 3 times 2 times 2, right? And how about 54? Sorry, how about 54? Yeah, how about 54? 54 equal to 3 times 2. It's not. It's like this. 3 times 3. Okay, so here, here, I need to write it in this way. The common part is 3 times 3 times 2. Okay, and here, the outside is 2. The outside, this is 36. I just rearrange them. I just rearrange them. So for 54 is 3 times 3 times 2 times 3, right? So the middle part is what? The middle part is 18. And this is the what? This is the GCF, right? And from definition, we know the common part is the GCF. What is the least common multiple? Least common multiple means I must find a common part. So if I add these two numbers together, if I add them together, I must times 3 and times 2, right? Is something like this. I find the common denominator. So the least common multiple should equal to 2 times the common part is GCF is 3 times 3 times 2 times 3. Okay, this is what? LCM, right? This is LCM. So you can see here, this is the relationship between LCM and the GCF. This is a different part. Okay, and this is a different part. We must times all the different part to the common part to get LCM, right? And from this Winnie graph, we know LCM, this is LCM, right? Equal to what? Equal to this times these two, and minus this, right? And minus this. So in multiplication, this should equal to this times this, and divided by middle part. Can see? Because these two numbers is 36 times 54 divided by the middle part. The middle part is what? Because 36 is what? Is 2 times 3 times 3 times 2. Okay. And 54 is 3 times 3 times 2 times 3, right? You can see this part I times for twice. Okay. If I divided GCF 3 times 3 times 2, okay. If I divided one of them, this is what? This is the greatest. This is the least common multiple. Okay. So this is the logic why we have this formula. Okay. This is the logic why we have this formula. So please write down the formula. If I need to calculate least common multiple, I can use greatest common factor to find it. Please write down this formula. LCM equal to A times B divided by GCF of AB. Okay. Now, sometimes we was asked to find the least common multiple of two fractions. Usually, greatest common factor works on integer, but least common multiple, sometimes we need to find work it on the fraction. So for example, I have 10/3 and 8/5. How could I do this? The least common multiple can equal to should equal to the multiplication of two numerator. Okay, the multiplication of two numerator and the GCF of A and D, you can see, and the C and the B. Okay. So for these two number, 10/3 and 8/5. So we can, so here we just we can use this and of this, both of them. So I just use the first one. So I just use write it in this way. Method 1. Least common multiple of 10/3 and 8/5. So this should equal to the multiple of two numerator, 10 times 8. And the greatest common factor of two numbers, these two numbers is 10 times 5. 10 times 5 is 50. And 3 times 8 is 24. Okay. So this is this should equal to 80 divided by 50 and 24 is what? The greatest common factor of them is what? 50 and 24 is 2. Okay. So the answer is 40. The answer is 40. Sorry. I want to move this to the middle. Okay, I want to move this to the middle. Okay, so method 2 is use least common multiple of this, but I don't suggest you second one because the least common multiple is difficult. It's difficult to find the greatest common factor. Okay, so I suggest you to use the middle one, not the right one. But I just introduce this method. Method 2. Least common multiple of 10 and 3, 8 and 5. 10/3 and 8/5. So firstly, I must find least common multiple of 50 and 24. And BD is the multiple of denominator. So the denominator of them is 3 times 5. Okay. So let me use my calculator to find it. So this is 600 and divided by 15, we also get 40. Okay, so I suggest you to use this one, not this one. Okay, because the least common multiple is difficult to find. It's more difficult to find than greatest common factor. Okay, so the answer of this is 40. Okay, I just give you two numbers to try. Okay, so now can you find? So please, firstly, please write down this formula. write down this formula, and then I will give you two numbers to try. So one is 1/3. The other is 1/2. Please find the least common multiple of these two numbers. Find the least common multiple of these two numbers. What's the least common multiple? Okay. So you don't know what's the GCF of 3 and 2. What's the GCF, greatest common factor of 3 and 2? Because they are relative prime. Because they are relative prime. So the GCF of 3 and 2 equal to what? Equal to 1. So the least common multiple of 1/3 and half is 1. Okay. So try another one. Try another one is 2/3 and 3/5. Okay. Please send me the answer to let me you understand how to use this. Two-thirds and 3/5. What's the least common multiple of these two numbers? Okay, don't know how to do this. So find what the product. The product of the two numerator is 2 times 3. And the GCF is this 2 times 5. Okay. And what? 2 times 5 and 3 times 3. Okay. You can see the GCF of 2 times 5, that's 15. And 3 times 3 is 9. They also relative prime, right? So it's 2 times 3 over 1 is 6. Okay. Clear about this method? Yes or no? So if you don't know how to use this, please type no. Okay. If you don't know how to use this, please tell me. How to use this? Okay. Please give me some response. Clear about how to use this. Find the product of two numerator and the GCF of AD times BC is cross product. Okay. Now, next question. So if I need to find the GCF of 3 numbers, how could I do? If I need to find the GCF of 3 numbers, how could I do? I just find the common part. This equal to 2 times 3 times 3. And this equal to 3 times 3 times 3. And this equal to 2 times 2 times 3 times 3. Okay, what's the common factor? What is the common factor? Please send it to me. Okay, I found, sorry. So now, just now I can't see your message. Sorry about that, but now I found I can. So here, thank you for giving me the answer. So the common part is this. Okay. No, no, I will introduce this method because this method is using coding. When you maybe in the future you will take some programming computation, and this method is also used for big number in math computation. We call this OC or Euclidean. Okay. How to use this method? For example, if I have 2 numbers, I want to find the GCF of 2 numbers. GCF of 2 numbers is something is 48 and 36. How could I do? I just use the bigger one divided by the small one. The bigger one, this is the large one, and this is the small one. Okay. I use the larger one to divide it by small one. I get the answer is 1, and the remainder is 12, right? So step 2, I use the small one to divide it by the remainder. 36 is the small one. This is the divider. Okay, divider, and this is the remainder. Divided by 12. Okay, so equal to 3, and the remainder is 0. So when you find the remainder is 0, okay, this is the greatest common factor. Okay. this is the greatest common factor. Okay, so let only one, the remainder is the 0. So in this situation, the divider should be the, yes, Kevin, you can. So the divider should be the GCF, okay? So you can give me two great numbers. You can give me two great numbers, maybe a little bigger. So in this way, I can show how to do this. Okay, for example, 106 and 96, okay? 106 and 96. Now, the GCF of these two. Find the GCF of these two. I just use 106 divided by 96. The answer is what? The answer is 1. And the remainder is 10, right? So I just use 96 to divide it by 10, okay? So the answer is 9, and the remainder is 6. Yeah, the remainder is 6. And the next step, I just use 10 divided, let me see. 10 divided by 6. The answer is 1, and remainder is 4. Okay, I just use 6 to divide it by 4. I know the number is 1, and remainder is 2. Okay, and the next step, I just use 2 divided by 4 divided by 2. The answer is 2, and remainder is 0. Okay, so when you see 0, you know this number is the greatest common factor. Okay. So this is how to use it. Of course, we can especially for very big number. These two numbers is not very big. You can use factorization. But if you change it to two big numbers, you can use this method. Okay, and this method is very easy for coding. Okay? It's very easy for coding. I just make this change. Okay, right? I just make this. I always do like this. So this is the reason why in coding, in programming, we use this method. Okay. Clear about this method? So you can try two numbers. I give you two numbers to try. So please try 84 or 48 and 80. Use this method. Emily already get the right answer. still give me the right answer. Okay. So of course we can use other method, but you can try this. I just use 80 divided by 48. I use 80 divided by 48. Aaron give me the right answer. Kevin give me the right answer. So the answer is 80 divided by 48. The answer I get 1 and the remainder is 32. Then I use 48 to divide it by 32. The answer is 1 and the remainder is 16. Thanks for Tony. Give me the right answer. So 32 divided by 16, I get 2 and remainder is 0. So I know at this moment the divider is the greatest common factor. Okay. This method is very useful for greatest for large numbers. Okay, so for three numbers, we use prime factorization for LCM. Okay, because there are 3 numbers. There are 3 numbers. So how to do this? You can use prime factorization, find them, and find the common part. Okay. Emily get the right answer, but the other student need to try again. So here. Here, I separate them in, I use the prime factorization method to separate them. Okay, and I found the common part is 3, right? So the common part only write for once. The common part I only write for once. And for one time. And the different part I need to write them all, right? So 7 is the different part. And I found, okay, for these 2 numbers, 24 and 48, they have common part is 2 times 2 times 2. Okay, so I just use this as a common part. Yeah, Kevin give me the right answer, and Aaron give me the right answer. So this equal to what? This other common part, right? So the final answer should equal to 336. The common part you use only once, okay? The common part use only once, and the common part you need to make sure all the different part should be included in your least common multiple. All the different part should be included, okay? Should be included in your least common multiple. Okay, so find the greatest common factor of these firstly, and then after finish, you can do the second one. Have you sent me the answer? Yeah, thanks for Emily. Great. Yeah, Emily find the right answer, and so this is about the second one. You must find the including, because why the answer is 12 is 14 x to fourth power and y to sixth power, because you can see I separate them I separated them like this, 2 and 7, right? And here x to fourth power and 3 to third power. I just find the biggest one. Who is bigger? X to fourth power. And this y to fifth power and y to sixth power. I need to find a bigger one. Find the larger one. Okay. And for this for the least this is for least common multiple, and the greatest common factor is should equal to 7 times x 3 and y 5. Great. You can use this method. You also can use this method. So yeah, it's 2. Yes, thank you. So this equal to 30. Okay. So we have 2 methods. Just now I introduced the first method, and the second question I used the second method. I just draw this graph. Draw this graph. I put the common part. The common part in the middle. Okay. The common part should be the greatest common factor. And then I just time the middle part with the different part. So this and the common part is 2a to a's power, b to third power. And the least common multiple, I just times this with the middle part with this together. Okay. We just multiply the 3 part together. So I get ab squared times 2a 2 to a's power, b to third power, and times 3, sorry, and times 3a squared. So this is the 2 method for greatest common factor and the least common multiple. Okay. So just now I introduced this, and could you please try these 2 questions one by one? Okay, Emily and Syria and Aaron, all of you give me the right answer. Okay, so they tell me the greatest common factor of 8 is 7, and the least common multiple of 8 is 70. So this equal to what? This equal to the product of two numbers is 14 times x. So I know x equal to 7 times 70 divided by 14. So the answer is 35. So it's D. How about next question? Still give me the right answer. Yeah, Emily give me the right answer. So now, step one. I just use prime factorization to get the prime number, prime factor of 1260, 1260. So I just get 2 square, 3 square times 5 times 7 equal to this big number. And I just get 60 equal to 2 square times 3 times 5. Now, I know I still need 1, 3, and 1, 7. But can this number equal to 21? No, this number must greater than this one. Because if our other number is 21, there are only one. The least common multiple should only 1/3, 1/3, not 2 threes. Okay, so here we must we must know at least the answer should be multiple of 21. The answer must be multiple of must be the multiple of 21. And in the selection, there are only one. And why there is 63? Here, I must write like this, because the common factor must select, the common multiple should use the bigger one. Okay, so this is reason. Thanks for Aaron. Thanks for Tony. Give me the right answer. Okay, so the answer is this. Okay. Now, now the difficult part is the word problem. It's the word problem. So how to deal with this kind of word problem? If we find some words like if we find some word like divided, that means greatest common factor. So, okay. So now, usually we have least common multiple greater common factor. Okay. Sometimes they are same. In what situation they are same? The numbers are same. If the numbers are same, LCM of M should equal to GCF of two same numbers. Okay. Only in this situation. And GCF is the factor of A and B. So GCF is less or equal than A or B. So they must GCF is less or equal than the minimum of A, B. And the LCM usually greater than the max of A, B. Okay. So in word problem, when you think about this, if you look for a number is bigger than A or B, we are looking for the least common multiple. If we are looking for the number is smaller than A or B, we just looking for the greatest common factor. Okay. In word problem. So try this one. Still give me the right answer. Okay. And still give me the right answer for 11. Okay, so because I must find least common multiple. Because I want to find a number bigger than them, so it's least common multiple of 3 and 4. And I know they are relative prime. They are relative prime. So this number is the product of these two numbers equal to 12. And so we want to find what? Find number less than this number. So I just greatest common factor of 36 and 63. So here. Yeah, thank you, Tony. Thanks for Tony. So here, this is we can use this. So you can see if I use this method, GCF, I just use bigger number to divide it by 36. We just find GCF to what? 36 and 63 minus 36, right? Just use find the remainder, find remainder. Okay, we can use this method. We also can use this equal to 3 times 3 times 2 times 2. This equal to 7 times 3 times 3. So the same part, the common part is 9. Yeah, I think all of you give me the right answer. Thank you. Next, find the common what for 3 numbers. Example 3, example 13. So we must find the least common multiple of 3, 4, 15. Yeah, all of you get the right answer. So because these two is related, prime, relative prime. So this equal to find 3, I find 12 and 15. So this equal to 120. How about next question? They found the largest 3-digit number divided by, they want largest number. So yeah, we can use this method. Firstly, I find the LCM of these 3 numbers is what? 3, 4, 5. This is relative prime. So this should equal to 3 times 4 times 5. This equal to 60. I want greatest 3-digit. I just find the 60 times 16 equal to. So this number is the greatest one. They want 3-digit numbers. So 15, please. And so you get the right answer. So how to, Emily, give me the right answer, okay? Erin, give me the right answer. So step one, I just write them all in prime factorization, right? I write them all in prime factorization. So I know 12 equal to 2 square times 3, 50 equal to 3 times 5, 20 equal to 2 square times 5. Of course, I must separate the 420. And 420, I get what? 2 square times 3 times 5 times 7. Okay, so I just use the method of let me find the pencil. So you can see here I have 2 square in this place, I have 3 in this place, and I have 5 in this place. I only need what? 7. No 7. So I just select 7. How about, yeah, Kevin and Tony, thank you. Give me the right answer. So thanks for Kevin. So example 16, please. Thanks for Eric. Give me the right answer. So I just find the common part. So from the question, I know 2 of each type added to them. So 60. So 62 was changed to 64. 46 changed to 48. 94 changed to 96. I just separate them as prime factor. I do prime factorization for all of them. So I get the common part is 16. So I need to find the greatest common factor. And the greatest one is 16. Yeah. Thanks for KV. Yeah, Emily and Emily and Tony give me the right answer. So you can see from the question, they have some words can tell me what's the number I need. You have a list. So if we get a list, we know, oh, this is one to least common multiple, right? Least common multiple. So I just separate these two numbers. One is 72, the other is 48. I do factorization for these two numbers. For 72, I get 2 cube times 3 square. And for 48, I got 2 to 4th power times 3. So the least common multiple is what? The least common multiple should equal to 2 to 4th power and 3 square. So the number is 144. Thanks for Siri. Give me the right answer. So now this is the number of t's. This is the number of t's, and they want for what? They want for GLB. Sorry. So this 144 divided by 48. The answer is 3. Okay, so they need yeah. 3. Thanks for Kevin. Now, how about question 18? Okay. Yeah. Emily gave me the right answer, and so we use the GCF times the LCM should equal to the product of A times B, right? So here, the LCM is 36, and the GCF is 6. Okay, so what's the product of these two numbers? Is yeah. Thanks for all of you. I think all of you get the right answer. Next question. Okay. So here, 1 is 36. Still give me the right answer. Still give me the right answer. 36. 1 is 36 and the other is 48. We must find what least common multiple, right? So here, this equal to 2 square times 3 square. This equal to 2 to 4th power times 3. So the least common multiple of them should equal to 2 to 4th power and 3 square. So this equal to what? This equal to 144. 144. So we need to know what is the changes to minutes and second. So I change this to minutes and second. This equal to 2 and the remainder is 24. Remainder is 24. So we know next time is 2 minutes later and 24. Great. 2 minutes later and 24 seconds. Thanks for Aaron. So think about it. Next question. Aaron, give me the right answer. They want to find a smaller number. So let's find the greatest common factor of 48, 72, and 40. Emily, give me the right answer. So change this to 2 to 4th power times 3. Change this to 2 to 3rd power and 3 cubed. 40. Yeah, thanks for Tony and Tony give me the right answer. And this is 40. 40 is 2 to 3rd power times 5. So you can see the greatest common factor of them. The greatest common factor of them is a 2 to 3rd power, 2 cubed. So this equal to 8. Yeah, thanks for Kevin. And Last two questions, please. So you must pay attention that they must meet at point A. Okay, they must meet at point A. So how to do this? They must meet at point A, not in other place. So how could we do this? Okay, nobody give me the right answer. Does anyone find a way? So, so we can think about this. If Alex catch Bob, Alex catch Bob, A catch B, A catch B in how many minutes? A catch B. This should equal to 400 because one circle is 400, right? Divided by 102 minus 80. Okay, so that means 10 minutes. Okay, okay. How about Bob? How about A catch C? How about A catch C? A catch C, we need 400 divided, right? So this is 8 minutes. Okay, I catch C at point A, at point A, at point A, okay? And then B catch C. B catch C is 400 divided by 80 minus 70. So this need minutes. So if they meet at A again, if they if they meet at A again, how many minutes later? LCM of 10, 8, and 40 equal to what? Equal to 40. So they will meet again at 9. Yeah, thanks for 29:40. Okay. We will meet again at 9:40. This question is a little difficult. So please look at question 23. Hmm. Hmm. Okay, do you have any idea? So step 1. For the bug, for example, I let this equal A and B, okay? In circle A, the bug A need how long to finish one circle? The time to finish one circle is what? Is 2 pi times 5 divided by 3 pi. Okay. And in circle B, the time to finish one circle is what? 2 pi times 2 divided by 2.5 pi. Okay. Step 2. We need to find what? We need to find LCM of these two numbers. Okay. Of these two numbers. How to do this? So I talk about step 1. I need to find the time to finish one circle. Yeah, Aaron gave me the right answer. To finish one circle. So for the bug A to finish one circle is what? The distance divided by speed, right? That means 2 pi times 5. This is the distance. Divided by speed, speed is 3 pi. So the bug A finish one circle is 10 over 3 minutes. Okay. And for the second bug, if it finish one circle is 2 pi times 2, the distance, divided by 2.5. This is the speed. So I calculate and I get 8 over 5 minutes. Now, they meet again in the point B. I must find the least common multiple of these two numbers, okay? So this equal to what? This should equal to 10 over 3 and 8 over 4. I find the least common multiple. I times numerator, 10 times 8. And I find the greatest common factor of 10 times 5 and 3 times 8. So the greatest common factor of these two numbers is 2. And the numerator, the product of numerator is 80. So I need 40 minutes to meet again. Okay. We use the greatest common multiple of two factors. Okay. So now, let me talk about two questions. You ask me. So, do you remember this question? So I need to find them firstly. So give me 1 minute. This is one is for 2019, right? This question. Let me see, 2019. I think it's okay. I didn't make this one. So I just use this. Okay, this question. Do you remember? After you read this question, so I have 4 marbles. I have 4 marbles, 4 balls. Okay, I have 4 marbles, but do you remember we do this question? We have 4 books. I have 4 books. I arrange them on my shift. I have A, B, C, D, 4 books. And I want 2 books put together. For example, I want to put B and C together. But I can put C and B, C and B in this, right? Okay. So we have, if I want to put B and C together, how many ways? I just use glue. I just use glue to glue this B and C together. So now I have 3 books, A, B, C, and D, right? A, B, C, and D. So if I if I don't, so how many ways to put them? I have 3, 2, 1. I have 3, 2, 1. 6 methods, right? but you can see I can put in BC or CB, right? So this is for BC. And other two is for BCB. So totally I have 12 ways, right? Now I don't want to put BC together. I want to separate them. That's the total minus together, right? That's total minus together. So here, they didn't want they put together. That means total minus together, right? Total minus together. What is total? The total is 4, 3, 2, 1. And together is what? Together is 3, 2, 1 times 2. Okay, just minus them, equal to 4 factorial minus 6 times times 2. Okay, so this equal to 24 minus 12 equal to 12 ways. Okay, thanks for Siri, give me the right answer. Okay. This according to the method of this question. Okay, just now I found this. I found this question, so I just share this with you. How could I reshare this? Okay. I just stop sharing and I must find it here in this place. Okay, in this question, do you remember? This question, you can, according to this one, they want to put together. They want to separate it. And I remember we do this similar question is in this place. They want a number not 7, I remember. Include a number and not include a number. So review this chapter. This chapter almost cover all the questions in AMC8. Okay, situation covered all the situations. Okay, please review this chapter. And about Kevin's question. So let me about Kevin's question. This one. Okay. Now, each week during last week after computing. This question is similar to the question 20 of 2022, I think. 2022, question 20. So here, show the students. So change from discover there was actually, so here now is 60 and I change this to 21. I change this to 21. They want to know and which of the following statement describe the change in mean median. So what is the mean? The mean is the average of them, right? So the mean should equal to the Monday is 20. The Tuesday is 26. The Thursday is 21. So now here, now is 60, right? And plus is 21. Is 22 plus 60. The last is 60, right? So this equal to 100. Divided by 5. Divided by 5, I get 20. 100 divided by 5, I get 100 divided by 5, I get 20, right? So the 20 will be changed from the meaning will be changed from 20 to what? I add here and I increase 5, right? I increase 5. So 5 divided by 5, it means increasing 1. Okay, so the mean increased by 1. These are same. How about the median? So in this graph, the median should equal to, I just arrange from the small to the larger. Is Friday is 16, and other is 16, and is 20, and this is let me see, is 22, and this is 26. Okay, so this is the original one, old, and the new should equal to 60, and this already changed to 21, right? So 20 and 21 and 22 and 26, right? So the median is what? The median, this is the median. The median was changed from 20 to 21. This also increased by 1. Okay, so the right answer is B. Okay, so median is I write them in the way of increase, and I found the middle. Okay, I found the middle one. This is how to do question 10. If you have a question, you can send me in WeChat. So after I finish my class, I will talk about this. Okay. Any questions? If no question, you can leave. Okay. See you next week.